刚才讲错了，我中文真的不太好。这个 presentation 大部分是英文，我不好意思。那么其实我有很多个 slides， 我们可能就是看一看之间怎么样做什么slides。我们也有那个 bill 要 present 一下，可能我可以先做 OpenStack 的东西，把 bill 回来我们就是看一看，就是放松看到 OpenStack 的事情。那么先问一个问题，我们有人写过一个 patch 在 OpenStack 到吗？请起来，起来，只有2个。那么你有问题的话，你可以问到他们一定比我知道很多。So those two guys have committed patches to OpenStack, which is fantastic. And anyway, OpenStack, it's really just this cloud software. We're going to talk about it today, and hopefully we can also get into the contribution process so that we can let everyone in this room have the skills that they need to make their first patch. But we've got a lot of slides, a lot of learning to get through, so let's get started. What can you do with OpenStack? It's pretty simple. It's cloud computing, right? So if you want a server, you make an API call. You obviously have a lot of parameters. You can say a certain number of gigabytes, certain storage, all this kind of thing. If you want to suspend it or snapshot it or terminate it, it's just an API call. Servers are accessible through the API. With OpenStack, there's also software-defined networking. So if you want to assign an IP address to a particular server, it's an API call. If you want to change the firewall to allow certain ports to a server, it's an API call. If you want to create a private network and have a really complex network topology with 10 different subnets, it's just an API call. Similarly for storage, you can make a hard disk whatever size you want and attach it to a server. It's an API call. If you want to snapshot that volume, back it up, replicate it, it's an API call. And similarly with object storage services, you can ask our friend over there from SwiftStack who works on them. If you have something that you need to store, anything at all, if it's a photo, any kind of object, any kind of data, really simple API and object storage. You just put the object and you can get it back. That's basically it. And you don't need to worry about where it's stored or how many replicas, because that's what object storage takes care of. So OpenStack has all of these kind of things. It's also got a dashboard, of course. This is the Horizon project. Those of you, does anyone know Django? Awesome, great. That also means a few of you also understand English, which is also very good. This dashboard is actually in Russian, which is quite interesting. But of course, everything, like I said, is an API call. So if you're on the command line saying boot a virtual machine, it turns into this HTTP post request. All of this information can be found on api.openstack.org. And of course, there's Python bindings. If you want to boot the server, you just import the client, give it some credentials, the particular virtual machine image, like Ubuntu Trusty, the size, and then create the image. And you can do that for disks, networks, objects, all that kind of thing. There's all Python bindings available. OpenStack is crazy huge. 我们有人从140多国家 140 countries, and at the moment there's more than 2,000 running competition. We do a lot of patches, a lot of companies involved, and a lot of members. We've also got some really cool users. People like BMW IT use OpenStack to make their fast cars go faster. PS4, all of the online stuff runs on OpenStack. We've got banks, we've got airlines, we've got the film industry, all of these different kind of companies around the world are using OpenStack. It's really serious. And this week we had a conference in Taiwan where we even got 1,400 people to come to this conference. It's so interesting. Basically, OpenStack is just a collection of RESTful web services. Each one of these things has an API. Compute service manages virtual machines. The image service manages virtual machine images. The identity service handles all of your AAA, authentication and access, this kind of thing. The network service manages the connectivity, and that's software-defined networking. Look that up if you're not familiar with software-defined networking. It's the future. And block storage is basically, you can feed it storage and then it will take care of dividing it up into logical units. So you can just give an API call and ask for storage. Really straightforward. And object storage, like we said before, that simple API where we just put and get objects. And of course, the dashboard. There's also the command line. Each of the OpenStack service is implemented as Linux daemons. So this is the compute service. You can see that there's 6 or 7 daemons inside the compute service. The daemons use Eventlet. Does anyone know Eventlet? Okay, so Eventlet's a really cool library. If you don't know Eventlet, look it up. It's basically used in OpenStack so that we can handle lots and lots of requests. We have a non-blocking I/O. Because if you're running a public cloud, for example, if you have 100,000 or 1 million servers, and all of the users that come with those servers, you have a lot of API requests. You don't want to wait. You don't want to block the I/O. So Eventlet is an important library. Has anyone used SQL Alchemy? Okay, everyone knows SQL Alchemy. Of course, OpenStack uses that for storing state in databases. But one of the most important Python things about how OpenStack is designed is the message queue. OpenStack is a shared nothing architecture. Basically means those daemons you saw before, you can run them anywhere, and you can run as many of them as you want. They have a little bit of state in the database, but mostly they communicate using the message bus. There are 3 different technologies that OpenStack can use for messaging. So when you deploy OpenStack, you just choose one. RabbitMQ, Cupid, and ZeroMQ. They've each got their own interfaces. So OpenStack has a library called Oslo Messaging that enables us to abstract all of that away. But the top 2 speak the AMQP protocol, and ZeroMQ is a little bit different. We'll talk about the message queue a little bit later. OpenStack is really big, really big. This is an outdated view of the architecture. There are maybe 6 new projects now, so we don't have time to go through all of them today, but I wanted to go through just the compute component to show you how the message queue works, just to give you an idea of how OpenStack works inside one service. So if we just follow a very simple request, say we want to start a virtual machine. So we use that code that was on slide 2 and just say, give me a virtual machine. What happens is, of course, the request comes into the API, and that could come from the dashboard, the command line, or directly from code, like some Python code. And the first thing that the Nova API service does with that request is it puts it on the queue addressed to the scheduler. So if you're familiar with message queues, you'll see what is happening here. But basically, this Nova scheduler, you could run 100 of them, for example, if you have a really large cluster. Basically what happens is all 100 Nova scheduler daemons will listen to the queue. And then the first one that sees the new start VM message will pull it off the queue and then delete the message from the queue. So it then acts on that request. Nova Scheduler then will look at its algorithms, because Nova Compute, this service over here, is what talks to the hypervisor. So you might have 100 servers or 1,000 servers where you're running hypervisors like VMware or KVM or Zen or Docker, or even bare metal stuff. Nova Compute is what handles that kind of things. So if you've got 100 servers doing that, you need to choose which one to put the virtual machine on. The Nova Scheduler does that and puts a message on the queue and addresses it to a particular compute node. The compute node then pulls it off the queue and starts doing things. So the first thing the compute does is uses the API of the virtual machine image service to contact the virtual machine image service to find that particular virtual machine image. I think we were using an Ubuntu trusty VM image before. And so it will download the virtual machine image from the API service. At the same time, it also contacts the networking service and says, I'm trying to start a new virtual machine. Give me all of the networking information, IP address, subnet, routers, how many network cards, all of this kind of thing. And so once it's got that information, the Nova Compute talks to the hypervisor plugin. So OpenStack uses a lot of plugin methodologies. In this case, the hypervisor could be KVM, VMware, Hyper-V, whatever. On the storage side of things, also use a lot of plugins. So you have some open code in the OpenStack tree, which talks to the API of the particular storage device or network device or hypervisor. And anyway, it asks the hypervisor to start the virtual machine. So that's a basic overview of kind of how the compute services work using a message queue. Does anyone have any questions so far? 英文很难吗？你要我试试一半英文一半中文吗 ？OK， 我先用中文好了。Okay. So OpenStack is designed to be a framework. It's really, really, really customizable. Everything's very modular. And I know everyone says that about their software, right? Has anyone written modular software before? Yes, it's always modular. But OpenStack actually has some very explicit design things. So, for example, the object storage, it sounds like someone's been singing too much karaoke with this microphone. The battery is turning out. So the object storage, for example, it has a pipeline architecture for requests, and basically you can write a little Python module, a single file, and then put it on that pipeline, and that will change how the request is formatted. For example, if you had a custom authorization system that you wanted to connect to, you just write a little Python module, plug it in the pipeline, and it will just work. The compute scheduler that works out which hypervisor the virtual machine should be on is also fully pluggable. So you could write the best scheduling algorithm in the world in a single Python file or Python module, and then feed that to the scheduler in the compute service. Of course, the dashboard's in Django, so if you've worked with Django before, you'll know how easy that is to customize and change your logo and add some new panels, that kind of thing. One of the cool things you can do, might not be good to do on the Wi-Fi in here. If you go to devstack.org, that's devstack.org, you can download a single shell script which will give you an all-in-one OpenStack environment that you can use for development. And of course, if you are doing any development on OpenStack, we encourage you to work with the upstream community. So this is what we're going to talk about a little bit. How OpenStack works is basically we have a 6-month release cycle. At the start of every release cycle, we have a big conference. And basically what we have is people in a room, just like this, only instead of a presentation, it will be an Etherpad or a Hackpad, some kind of tool where everyone can edit at the same time. And we're having a big discussion about this new feature and how it should be designed. And anyone can join those sessions. You don't have to be an OpenStack developer. So we also have users coming to those sessions. And everything is open. Once that kind of initial discussion, the in-person discussion has happened, we then take that Etherpad and turn it into a more formal specification, which we call a blueprint. All of the blueprints are developed in the open. They're actually put into our coterie system. And I want to talk about our coterie system quite a lot today because I think it's really cool, the way that OpenStack does coterie.
So once the blueprint's been agreed on, it's been approved, it's been looked at, someone will volunteer to code the particular feature, or several people, a team of people, and then it gets put into the code review system. So OpenStack does not do pull requests on GitHub. I've got to say that again. OpenStack does not take pull requests from GitHub. Absolutely every line of code in OpenStack goes through the code review process. And the code review process, every line of code in OpenStack has been read by at least 3 people. At least 3. Normally 6, sometimes up to 20 people. The quality of OpenStack code is very high. That's just the human side of things. So the other point is, there is only one account that is able to commit to the OpenStack code repository, and that account is a robot. Everything comes from the code review system. OpenStack, for every single patch, builds an entire cloud. So we build something like 700 or 800 clouds per day, because for every single code change, we actually build the entire OpenStack cloud to do continuous integration and testing. And that means that the trunk of OpenStack always works. And then eventually, if you manage to get through all of this process, passing the human code review and testing, it'll be part of the release. And all of this is done in the open. Anyone right now can get your laptops and go to review.openstack.org and participate in the code review process. You can pick a random patch and go, -1, this is crap. Anyone can do that. One of the interesting things about OpenStack is there's also a lot of big companies involved, like Dell, HP, these kind of guys. And it's really interesting because their engineers work together on the same feature. But anyway, all of the documentation, translation efforts, even the testing infrastructure also follows the same review process. So, this is going to be really difficult to see, isn't it? But I'll show you this quickly and then I'll jump to a real one so we can zoom in. But this is a code review that I picked up on Monday. Basically, you can see there's a commit message at the top. You've got the details about the author and when they submitted it. I mentioned that OpenStack does a lot of testing. This entire column is tests that are being run. This particular patch is for the software-defined networking project. So here you see NEC CI, Huawei CI, Cisco CI, Mellanox CI. So what this is doing is actually running OpenStack networking on equipment from Cisco. Somewhere in the world, Cisco has some switches and routers and some servers, and they're running this patch just to check that it works with their equipment. On the left-hand side, we have people. So you can see there's actually quite a lot of people there as well involved in looking at this patch. And so you can see even more testing. There's a lot of testing. But it's actually all automated. So you can just upload your patch and the tests will automatically start. You don't have to do anything. And then finally down the bottom, we can see that there's been 3 different patch sets uploaded, and we can see the files that have been changed. This is just Garrett, by the way, so if you've seen Garrett before, you'll know what this is. And then you can see that there have been some comments on this code. And so if you actually open the first file, sorry you can't see this, I'll grab one we can see in just a second. You can see that basically Mibu-san has written sg-enabled equals config.conf.securitygroup.enable security group. And some guy, Chen Wen, has said, instead of directly using the config, we should call is firewall enabled in neutron.securitygroups/rpc.py or something like that. And so this guy has caught something that probably would have worked, but is a bad coding practice. And so Ryota Mibu says, okay, I'll fix it in the next patch. This is something that happens every second of every day almost. These people working together, they're from different companies, different countries. They're both Python engineers and they're both helping each other write better code. So I just want to quickly grab a patch that we can maybe see. How's this? Can people see this one a bit better? 你们会看到吗？看得清楚？ Okay. Okay, so this is a patch to the object storage service. You can see the commit message here. It's fixing a bug. Return the correct number of change petitions. So something petitions happening inside Swift. And you can see, same deal. There's some guy, Christian Schroeder, maybe a German guy, and you've also got the code review system. So this patch has just been improved. You can see that there have been 4 people who looked at this code, and it's been approved after the 4th person has looked at it. You can see as well that it's passing all of these tests, apart from these 3, which I happen to know are non-voting tests. So OpenStack does so much testing that sometimes we add tests which are just, we're testing new tests, so they don't count yet, but we're trying to fix the test. Anyway, and you can see that this actually went through 7 different patch sets before it's being, oh there we go, he's actually from Innovance, which is in France. And you can see there's comments here, one minor thing. If we actually look here, we've got the same kind of deal, you should use part here instead of fetching self.replicate, which should be the same, all you're right. So this is the OpenStack code review process. Any questions so far? Is this scary?
Who can approve?
Okay.
For people, so who can approve?
Yeah, cool. So in OpenStack, we don't have the concept of a core developer. Instead, what we have the concept of is a core reviewer. So we actually believe that code review is more important than development. So you can see over here, we've got 2 guys who gave a +1, and then 2 guys which have a tick. A tick is actually a +2. So these guys are core reviewers. And basically what that means is they've spent a lot of time reviewing code in OpenStack, and they understand all of the code base in Swift. And so we have a rule, which is you need at least 2 core reviewers before you can get the approval tick. So you can see 4 people were involved. Actually, most of the comments came from the non-core reviewers, but then the core reviewers can come in and do a review and approve like that.
Is this like the whole system? Is there a project that you can try, like if you wanted to use it within your organization?
This is just Garrett. Garrett. So basically, we use Garrett, and it's pretty standard Garrett. We don't make any patches to Garrett, but you can configure Garrett quite a lot. And so all of this testing stuff is just running in some custom software. But Garrett has the ability to talk with Jenkins, and Jenkins runs those tests. Yeah.
Basically, everyone can configure his own Garrett instance and into Jenkins future development.
So no, we never use Jenkins directly because we do so much testing and we have so much infrastructure that basically we rely on going through Garrett, because we don't just use Garrett connected directly to Jenkins. This is an entire talk I could spend an hour on, but we have a whole lot of glue things because, for example, we found that Jenkins doesn't scale with the amount of testing that we use. So we actually don't just run one Jenkins, we run about 20. And we have a whole lot of infrastructure that glues between the different Jenkins and tries to make it scale.
How can developers test their changes before they actually send pull requests?
Basically, all you need to do is clone the repo and run tox. So all of the testing stuff you need is in the repository. That will, of course, build an entire OpenStack cloud, so you need to have enough RAM on your laptop to do that.
How big is that?
Look, I mean, if you've got 4 gigs of RAM, that's plenty. But you don't have to run the entire cloud if you don't want to. If you're just making a small change, you can just run PEP8 and the unit tests, for example. And then you can just upload it to the code review system, and it will run the full test.
Does the process require 100% test coverage?
Test coverage varies depending on the project. 100% is the aim, but 100% in a distributed system where each of the parts are acting on their own, it's a little bit challenging to ever determine if you've got 100% testing. But quite a lot of the line of code count of OpenStack is tests. Yeah, we love more tests, lots and lots of tests. Yeah, and like all of the easy tests are done. So OpenStack is 100% PEP8 compliant, for example. That's required. But it depends on the project. Some of the newer projects haven't reached 100% testing yet. Any other questions?
Customizing which databases. So if I wanted to start with something kind of small and simple, even maybe something local, like what kind of, maybe I'm not understanding it correctly, but how could you change, like I want to program it so I can extend it in the future when I have more resources. But in the beginning, of course, you don't need a big system.
Right, sure. So it sounds like you want a cloud.
Kind of, yeah.
Yeah, okay. So if you want a cloud, there are already a ton of public clouds you can use. If you've got a credit card, you can go to HP or Rackspace or Innovance or even GigaCloud in Taiwan and just sign up there. If you want to try out the APIs without spending any money, there's a website called tristack.org, and you can just get a free VM there for a day at a time. So check that out. Okay, so I've been talking for about 30 minutes. What I've got in the rest of the slides is basically going through the process of submitting your first patch in more detail. We've got an option now of taking a break and listening to the Chinese language presentation instead of English, and then coming back to the more detail afterward. But I looked at guidance from you as to what you want to do.
Okay.